1. Hook. One simple config change took down an entire production system for a startup. Curious how that happened? Let's break it down and learn how to avoid this in your own projects. We often think we know what we're doing, but a tiny oversight can snowball into a major disaster. 3. The simple explanation: when we talk about configuration changes, we're referring to adjustments in settings that govern how applications run in the cloud. These changes can involve anything from security settings to network configurations. Understanding the potential fallout from these adjustments is essential. The key concept to grasp is that every service or application has dependencies. A change in one part can affect another. That's why it's vital to approach config changes systematically. 4. Real-world example. Let's look at a real-world incident from a startup called TechWave. They were scaling their web application to handle a surge in user traffic. The team decided to increase the instance size of their database server from a db.t2.small to a db.t2.large, expecting better performance. However, the DevOps engineer accidentally altered the database's endpoint URL in the application configuration. They didn't check the application logs after deploying the change. Within hours, user complaints flooded in. The app was unresponsive. In a matter of 6 hours, they lost around $15,000 in potential revenue, and customer trust took a severe hit. The root cause: a single incorrect line in the configuration file. 5. What to do instead to prevent this kind of disaster. Follow these steps. 1. Review dependencies. Before making changes, identify all dependencies. Ask, what services rely on this configuration? Use tools like AWS Config or Azure Resource Graph to visualize dependencies. 2. Backup configuration. Always back up your current configuration before making changes. Use version control tools like Git. Implement snapshot mechanisms for critical environments. 3. Test changes in staging. Create a staging environment that mirrors production. Test your changes here first. Use tools like Terraform or Ansible to automate deployments. 4. Use feature flags. Implement feature flags to toggle changes on or off. This allows you to roll back quickly if something goes wrong. Use tools like LaunchDarkly to manage flags effectively. 5. Monitor and validate. After deployment, monitor system performance. Check logs for errors or anomalies. Set up alerts using services like CloudWatch or Datadog to notify teams of issues. 6. Common mistakes. 1. Skipping dependency checks. Avoid it by using dependency mapping tools and ensuring all team members are aware of interdependencies before making changes. 2. Not backing up configurations. Avoid it by always using version control. If you're on AWS, use AWS Backup to create backups of configurations. 3. Failing to test changes. Avoid it by always having a staging environment to test changes. Make testing a mandatory step in your deployment process. 4. Ignoring monitoring tools. Avoid it by implementing logging and monitoring from day one. Use centralized logging solutions like ELK Stack or Splunk. 5. Rushing deployments. Avoid it by establishing a deployment checklist to ensure all steps are followed before pushing changes to production. 7. Quick checklist before making any config changes. Use this checklist. Identify and review dependencies. Backup current configuration. Test in a staging environment. Implement feature flags for safe toggling. Monitor performance after deployment. 8. Summary plus CTA. Today, we explored how one small configuration change caused a major outage for a startup. By understanding the real problems, taking actionable steps, and avoiding common mistakes, you can prevent similar disasters in your projects. If you found this video valuable, share your thoughts in the comments. Let's learn from each other's experiences. Don't forget to subscribe for more practical insights into cloud engineering. Bonus practical tip: if you're unsure what to pick, start with the simplest option that ships today. Then measure for 7 days, latency, errors, deploy time, and cost.